sums. So with the gorilla problem, we had to kind of estimate, make some guesses, say, I don't know if this is really the right thing, but this is what I'm going to try. Okay, this guy Riemann, he formulated like some very specific ways to do certain estimations, and that's what we're going to do. Okay. Sometimes we're going to be able to check against the real accurate answer. Sometimes we're not going to really know how accurate our answer is. Okay. But we know that using these specific types of things called Riemann sums, that gives us the best estimation that we know how to do. Okay, over a few hundred years. So a car is traveling so that speed is never decreasing. So the idea here is that there's not really weird things going on. It's just consistently increasing the whole time. All right? And so over this 12-second interval, so this is kind of similar to the gorilla problem. All right? It's just a car driving though on the road. We're given a table of data. You're given a graph. I know these numbers are really tiny, but guess what? They're the same numbers that are in your table. So if you can't read the numbers on the graph, just look at the table. All right, so we're going to do different things of Riemann sums. We're going to do a left Riemann sum, a right Riemann sum, and a midpoint Riemann sum. And then there's a fourth kind that we'll do on the next page. So a left Riemann sum means, okay, first of all, let me back up. 3 subintervals of equal length. Now, if I'm talking about a total span of 12 seconds, what is each subinterval if there's supposed to be 3 of them? 4 seconds each. So that's what I want you to do is kind of like mark off 3 different subintervals. Okay, the next thing is, so like in other words, we're going to look at this as from a more geometry type standpoint here. Okay, we're going to use an actual rectangle. All right, and so in this rectangle for a left Riemann sum, you're going to look at these 3 points right here, and you're going to pick the left one. And that's going to tell you how tall your rectangle is going to be. So it's going to be this tall. Okay? And so we're going to pick 5 for that number, in other words. And then the base of this rectangle would be 4. So what 5 and 4 represent is 5 is the number I'm going to use for my speed, and 4 is the number that I use for how much time has passed. And I'm going to multiply those, right? We multiplied them in the gorilla problem, and we know for sure when we take area of a rectangle, we multiply. So 5 times 4. And you can go ahead and say that's 20. You don't have to. You can wait to the end to just do the crunching of the numbers. All right. Now, in my next little rectangle, I have 3 new points to choose from. And remember, this said left. So out of these 3, I am going to pick the left point to tell me how tall my rectangle should be. So there's my rectangle right here. So how tall is this second rectangle?
21.
21. Again, if you couldn't read that, then you could look up here and say, oh, when time is 4, speed is 21, that's that height right there. So we would add 21 times 4. Okay, the third rectangle, how high is that going to be? 45, right here. So 45 times 4. And then we're going to multiply and add all of that up. And you can definitely use your calculator for this. Some of these will end up being no calculator problems, but the numbers will generally be really easy when that's the case. So this ends up being, I'm not going to spend a lot of time on this, it ends up being 284 feet. Now there's a couple of reasons why I know my units are feet. Number 1, it said estimate the distance traveled by the car. So that's feet, right? Not feet per second. The big reason, though, is think about what you've been multiplying. You've been multiplying a velocity, feet per second, times a time, which is seconds. What happens to these seconds? They cross off, and you're left with just feet. So a lot of times the units really help you understand really what's going on in the problem, and what's going on in the problem helps you understand what units you need. Okay? And that's a Riemann sum. This right here is an estimate for how far this car traveled. Now, overall, do you think this is a good estimate? Or do you think it's too big or too little, or what?
Too small.
Do you think it's too small? Why? Why?
You missed out a bunch of points.
So, like, for the whole first 4 seconds, I'm saying that this car traveled 5 feet per second, but actually it traveled faster and faster and faster. So if the car is traveling faster, it should be going further than what I've estimated. So this is a very low estimate, okay? It's not great, but it's good, okay? And I did what they asked me to do in part A. All right, so now we're going to do a right Riemann sum. And it's pretty much like what you think. Notice that the 3 thing, that didn't change, but I have a right Riemann sum. So I'm going to do this actually in a different, I'm going to do this in a different color here. I'll do this in blue. So again, in the first rectangle, out of these 3 points, I'm going to pick the right point. So I'm doing this one in blue, and now I have a new rectangle, and it's a bigger rectangle. So if the other one was an underestimate, this one seems to be like an overestimate. And so the first one would be 21 times 4. Okay, that first rectangle is 21 by 4 multiplying. Okay, what about the middle rectangle? How high should that one be?
32.
So 32 would be in the middle, and we're going to get to that. 45, right? Do you see how, like, they're kind of shifting over one? Like the rectangle that was in the middle is now on the left, the rectangle that was on the right is now in the middle. So there's a lot of repetition here. So I would add 45 times 4. And then lastly, I need to go up just a little bit, it'd be 65 times 4. Another thing, you might have picked up on this on the first one, maybe not, if you wanted to, as far as when you're typing this in, you could do something like that. You don't have to go this times 4 plus this times 4 plus this times 4. You could just do a single 4 times and then add them up. Just be careful with your parentheses and all that. All right, you should be getting 524 feet for that. And this would be an overestimate. So the best answer really probably lies somewhere in between. So these, the left and the right, one of them's under, one of them's over. It depends on the graph which one is which. It's not that left is always under or vice versa. But we're going to get into some that are a little bit more accurate. So the next thing we're going to do is the midpoint. All right, and so in the midpoint, okay, again, we still have 3 subintervals, so let's do what we did before. We marked it off at 4, 8, and 12. And we're not picking the left or the right. We're picking the point in the middle. Now, I want to be really clear here. It's the mid part of midpoint means the middle x. It doesn't mean the y is in middle, okay? Like 12 is not exactly in between 5 and 21, right? It's not. But 2 is exactly in between 0 and 4, okay? If you just stick with, I'm picking the middle point, you're all right. But some people try to make too many connections that don't apply. So what's the height of this first rectangle? 12. And that would be 4. And some of you maybe can start thinking about, how could I do this if I was given a graph or given a table and not a graph? And sure, I could make a graph if I wanted to, but could I do this with just the table? That's kind of some things that are coming up in the future. All right, the next rectangle, we have 3 points to choose from. Choose the middle point. So that would be 32. This is where we use the 32. So I got 12 times 4 plus 32 times 4. And then what would be the last one?
54.
54. And so for this, we get 392 feet. Now, this answer is in between my answers for A and B. So out of A, B, and C, which answer do you think is the best answer so far?
C.
C. Definitely C is probably closest to the most accurate answer. Again, we can't find the accurate answer unless we have like an equation or we do like infinitely many rectangles, which I don't have time for that. All right, so turn on the page. And we did rectangles. We liked rectangles. Rectangles are real basic and easy to work with and all that. And then we have this one that's a trapezoid. And trapezoid gets a bad rap. People tend to be like, oh, I love rectangles, but I hate trapezoids. Okay? A trapezoid is just a slightly odd rectangle. It's like someone that you don't think you're going to be friends with, and then for some reason you get to know them and you're like, yeah, I like that person. They're my friend now. Okay? So think about it like this. Okay? I want you to draw this trapezoid up at the top. Because some people are like, well, I don't remember the formula. Well, I'm not giving you the formula. If you don't remember it by now, you're never going to remember it. Okay? Now, with rectangles, you just did base times height, right? All right? The thing with the trapezoids is there's two bases, and they're not necessarily the same length. Okay, so all you're going to do is average the bases times the height. That's all you do. I'm not giving you a formula. You know how to average two numbers. You add them up and you divide by 2. That's why the formula, if you remember the formula, that's why it works the way it does. Okay, so in looking at this problem, 3 subintervals, okay, we always got to start with the subintervals, by the way. You can't just start drawing rectangles or trapezoids. You got to break it up the way it's supposed to be broken up. And then from there, decide what picture you're going to draw. So on the previous page, I drew rectangles with each of these 3 points. Here, what you're going to do is you're going to take the left point and the right point, and you're going to connect them to make a trapezoid. Now, it may or may not cross through this point right here. I don't care. In fact, we are not going to even use any of these middle points at all. All right? We're only going to, it's kind of like you're combining left and right. We're not doing anything with the midpoint. So this was 5, and this was 21, and this is 4. So if I want to find the area of this trapezoid, I'm going to average 5 and 21. So not a formula, just average 5 and 21. And then multiply by 4, just like how we did before. This is something you can remember, even if you're really bad at memorizing formulas. If you're good at memorizing formulas, then by all means, keep doing it. That's fine. So looking at the next trapezoid, combine the left and the right. And again, don't worry about, are you hitting that middle point? It doesn't matter. Okay? It doesn't matter. Sometimes there won't even be a middle point there to even worry about. So this time we're going to average 21 and 45, and we're going to multiply by 4, because that's the distance from 4 to 8. So 21 plus 45 times 4. All right. What numbers are we averaging on the last trapezoid? 45 and 65. Now, sometimes on this, students start seeing like, ooh, I can kind of say that 2 and 4 simplify to make 2. That's fine. You can do that. You can pull the 2 out. It doesn't matter. Either way, if you, though, are going to type this all in at one time, just be careful about your parentheses. I really don't care how you type it in, but you got to be accurate here. You can't do all this right and then mess up when you're typing it in. So just pay attention to that kind of as you go through and you're practicing. So I get 404 feet. All right, so then we're going to answer some questions about these 4. So there's no more. There's 4 types. We did the 4 types. Left, right, midpoint, and trapezoidal. Okay? Which of your answers is an under approximation? Now, we already answered this, but can y'all remind me? Which one was an under? The first one, which was left in this case. It's not that left is always under. That's not true. In a different graph, left could be over. But in this case, left was under. Which of your answers was an over? The right one. Again, that's not always true, but it was true in this case. Okay, and then it says calculate your average, or calculate the average to parts A and B. So you don't have to go back over. I'm going to remind you that those answers were 284 and 524. So to average these, we will add and divide by 2. Again, if you're going to do this all in one step, put parentheses, and you get 404 feet, which sounds familiar. That was the same as the trapezoid. And this is always going to happen. If you find the left and right Riemann sum and average them, it will always be the same as the trapezoid. This is a really nice way to check your work. So then, here's the big question. Which answer is the best? Left, right, midpoint, or trapezoid? You think trapezoid? I will tell you, in general, it could be the trapezoid or the midpoint. It's just going to vary from problem to problem. Okay, and especially it varies on how many subintervals you use. All right, so you can't really say there is a best unless you have an equation, and your calculator will, right now, eventually we will learn how to find the exact answer, but right now we're just going to rely on a calculator. Okay, so this is a problem that I'm talking about. We're going to work through these one more time, and then I'm going to show you how to do this in your calculator, and then we're done. So this is a problem, though, where, hey, they don't give us a table, and they don't give us a graph, so guess what we get to do? We get to come up with it. Now, again, you get your calculator, so don't worry about the number crunching. Let's look at this x-axis first. Okay, it's 0 to 2, and how many subintervals are we going to have if we look ahead? What does it say in part A?
4.
4 equal subintervals. Okay, so breaking this into 4 looks like this. And so how much is just one subinterval? 0.5. So let's mark that down here. You could definitely use 1/2. Since we get to use our calculator, I'm going to go ahead and use decimals instead of fractions. If we were having to do this by hand, maybe you would want to do fractions. All right, now there's no points drawn here, so we get to figure them out. So we're going to take the x value and we're going to plug it into our equation. So 0 squared plus 1 is 1. Now I'm going to plot the point and then I'm going to write that number. You could write the ordered pair 0, 1, but the part I really care about is just the y value, the 1. All right, what about 0.5 squared plus 1? 1.25. What about 1 squared plus 1? 2. 1.5 squared plus 1? Use your calculator if you need to.
So 3.2.
Yeah, 3.25, good. If we were like without a calculator, I would encourage you to change that 1.5 into 3/2 and do it that way, but you get a calculator. And this makes sense because this is a parabola shifted up 1, and this looks like half of a parabola. 2 squared plus 1 is 5. Okay, so moving on with the problem. A left Riemann sum. All right, so my first group. Okay, am I choosing 1 or am I choosing 1.25? 1. If you need to draw the rectangle, draw the rectangle. If you feel like, I don't need to draw it anymore, you're fine, you don't have to. The picture over there is not mandatory. It's really just there to help you with the problem. Okay, so that would be 1 times 0.5. What would the next rectangle be? 1.25 times 0.5. And if you notice, again, we're multiplying, like last time we were multiplying by 4 each time. This time we're multiplying by 0.5 each time. All right. The next one would be 2 times 0.5. And then the last one would be 3.25 times 0.5. And you're going to want to use your calculator for this. I think I'd have these answers memorized by now. Okay, you get 3.75, and there's no units because this problem doesn't have a context. So again, let me kind of emphasize here. 3.75 represents the area of all four of these rectangles, which is estimating the area underneath the curve of the parabola. So do you think these rectangles, if I kind of drew like a dotted parabola here, do you think these four rectangles are an over or under estimation of what the true area under the curve would be?
Under.
Under, right? And they asked us why on this one, so we got to give a reason. And really the reason is just because f of x is increasing. Now I'm going to talk more about this later, but what if you had to prove that f of x is increasing? Could you do that? We did it all last semester. What would you have to say?
The slope is positive.
So let's use a calculus term. The derivative is positive. F prime is positive. Okay, so we could prove that if we needed to. I'm just throwing that out there today. We'll talk more about it later. All right, so the right Riemann sum, I'm going to write this down really quickly, but I'm not going to draw it, okay? And this time I'm going to go ahead and just pull out the 0.5 and think about, okay, which numbers really make it on this. It would be 1.25 plus 2 plus 3.25 plus 5. This is one way to do it. Okay. But in general, if you can do a left, you can do a right, and vice versa. They're the same type of thing. And this one would be an overestimation for the same reason, because f of x is increasing. All right, so now for something that's more interesting, a trapezoidal Riemann sum. All right, so I'm not going to redraw this. You can, but I just want to go ahead and stick with the graph that we have, okay? So it would be where you connect these two. And so remember, when you do trapezoidal, you're averaging two numbers. And the two numbers you're averaging, in this case, are 1 and 1.25. So you're averaging them, and you're multiplying by the time interval, which is still 0.5, like how it was up here. And so that's one trapezoid. So the next trapezoid would be 1.25 plus 2 over 2 times 0.5. Okay, because you're trying to find that area right there. And even as I draw this, you can kind of tell that the trapezoid is giving me a more accurate answer. It's following the curve better. Not exactly, but better. Okay, the third one. What two numbers are you averaging for the third one? 2 and 3.25. And then the last one would be 3.25 plus 5. And you get 4.75. And I know I'm going really quick over the calculations, but that's something that you can kind of work out on your own. All right, now remember what we said about trapezoid? It should be the average of these two. It should be exactly in the middle. Is it?
Yeah.
Yeah, it is. So that's an easy way to check. All right, is this an over or under? Now, let me, okay, here's what I want to do. I want to show, I'm going to draw this right here. I'm going to draw one of the little trapezoids. Now, truly, the graph of the parabola is concave up, right? Would you say that x squared plus 1 parabola is concave up? So this right here is really what I'm trying to find. This would be the best answer, but we don't have a formula for that shape. So what we were doing in this problem is we were connecting this point to this point, and we were finding the area of the whole thing. So is this trapezoid's area, is that over or under what I had shaded kind of in that black color? It's over. Okay, the green is over the actual curve. Why? What about this? And I kind of gave you a hint. It has to do with the function. And it's, what do we call the way it's curved? Yeah, but what do we call
Exponentially increased.
concavity?
Cavity.
And this is concave up. And that's all we're going to write. Now, could you prove that this is concave up? Sure, you could with second derivative and all that. Okay, we'll talk more about that another day. If this thing was concave down, this would have a reverse effect. All right, midpoint. Now, good news for you guys. I'm going to make your life a little bit easier, and I'm going to change this 4 to a 2. You don't even know how much easier this is going to make your life. All right, you're welcome. Okay, so let's redraw the graph. Just because there was a whole lot going on, I feel like too much at that point. Okay, so that's the same graph. So if we changed it from n equals 4 to n equals 2, how much is just one little subinterval? 1, right? So like in this case, this, think about that. This is one subinterval, and this over here is the other one. Okay? Do you have a midpoint of the 3 points?
Yes.
Yes. Okay, and that's the one you're going to choose. Now, let's just finish this and I'll explain what would have happened if I didn't change it. So this is a rectangle again. Remember, they're all rectangles except for the one trapezoid. So midpoint, Riemann sum, that's a rectangle problem, just like left and right. So I would say, okay, that's 1.25, but I'm not multiplying by 0.5. I'm multiplying by this whole base right here, which is 1. So times 1. So the fact that I changed how many subintervals I had changed how long just one of them is. All right, plus, okay, what would the next one be? 3.25, again, times 1. And you get 4.5. Which is pretty close to 4.75. So these are both pretty close. If I had not changed it, if I had left it like as n equals 4, okay, where this is just one subinterval, do you see how there's a problem? Because I don't know what that point is. This means I would have to go back to the original function and plug in like 0.25 and get that number, and it's just more work.
If we did that, would we still get?
You would not. You would not. You would get something very close to this. But let me ask you, if I used more rectangles, do you think that would improve the accuracy or hurt the accuracy of the problem? Improve. The more rectangles you have, your answer will always improve. And more trapezoids you have, your answer will improve. And so it would be, and let me remind me, and I'm going to come back to that in just a second. So turn the page, and if you have your 89, I want you to get that ready. So first of all, there's 2 typos in E. First of all, this, we got to change this to what our actual example was. That was my fault. And second of all, this F4 needs to be F3. So after we move away from Riemann sums, okay, we're going to do Riemann sums. We're going to have a quiz next Tuesday, and then Wednesday's like really weird, and then next Thursday, so a week from today, I'm going to teach you how to do this stuff by hand and really accurate and all this stuff. But right now, I just want you to kind of see like what the exact answer would be. So this right here is the notation. See how that kind of looks like an S? I'm not going to say it is S. It's more complicated than that. But it's not a bad idea if you associate it with S for summation, okay? 0 to 2, that was my interval of x, and here's my function, and dx is saying basically this is the derivative, because we're going backwards now. We're given derivatives, velocity, rate of change, and we're going backwards. All right, so this is how you're going to do this in your calculator, though. Oops, wrong thing. Okay, here we go. So you're going to go to F1. No, what am I saying? F3. You're going to integrate. Remember, differentiate, F3, that's all we knew. Now we're going to differentiate. And so it looks like that same symbol. We're going to type in the equation. If you don't have your calculator with you, you need to be writing these steps here. It's not a main point of this unit, but I want you to write it down so that you know how to do it. And then what do you think comes next? Comma X, of course. Now the only thing different is we're going to put in the numbers, the bounds. Okay? So I'm going to go comma 0, comma 2. And what this will do is it will find the area under the curve from x equals 0 to x equals 2. And those numbers would change the answer. But these are the numbers we used. We were in between the bounds of 0 and 2. Now if I press enter, it will give me 14 thirds. Okay, so I'll write that down. Whoops. 14 thirds. If I want to, this is a decimal. I'm an enter, and I get if I round to 3 decimal places, 4.667. Which is pretty close to my trapezoid and my midpoint. So those were not, like I said, those were not bad answers. If I had done even more subintervals, my answer would get closer and closer and closer to this. So my question is, which one was a better answer, the trapezoid or the midpoint? Which one is closer to this 4.667? If you need to, like, you can actually subtract them in your calculator. Like 4.75 minus this number minus 4.5. It's not exactly in the middle. Trapezoid is a little bit better. Now, if I had kept it, because I have the work written out here, if I had kept that previous problem at n equals 4, that answer would have actually been more accurate than even the trapezoid. Okay? But the thing is, you're not going to know this. This is just for kind of me to show you. And we're not going to get to number 3 today. I didn't get to it in any of my other classes. I think we have time, but I'm just going to call it quits. I'm sure y'all are okay with that.